All right, let's walk over to the workbench. And this is the duplexer we're going to tune today. We're going to be tuning the band pass and the band reject on all four of these cavities here. This is a Motorola T1507. I looked it up on the internet here under the Repeater Builder website, T1500 model. And let's look at the specs real quick here. Let me pull it down here. You can see this is very extensive. It has all the information in here about it. This is the configuration that we're going to be, our final configuration with 4 cavities. Okay, and then let's see. Inside there's a couple of things we're tuning. These are some stubs that will actually be moving to tune the reject frequency. And let's see what else we got here. Here's some of the waveforms that we're going to be looking for right here, and the amount of attenuation that we get. And you'll see that on the spectrum analyzer here in a minute. Let's look at the specs real quick on this thing. If I can get there. Here we go. We're going to be doing the T1507 right here. If you look, it's a 5 meg wide split. Minimum, let's see, receiver isolation. It's a minimum of about 55 dB, same on the transmitter. It has 2 dB insertion loss on the receive side, 2 dB insertion loss on the transmit side. Now, these have a lot less insertion loss, but look, they're very narrow. 470 to 512. This one is 406 to 430. They're very much more precise. They also have a higher rejection, but I think the reason this one has lower specs is because the range it covers the range of all these right here. All right, so I think we're doing good there. Let's get back over here now. I don't have a lot of experience tuning duplexers. It's kind of new to me. I had repeaters on 50, 60 years ago, but I never had to tune duplexers. And we didn't have the equipment back then that we have today. For instance, to really do this right, we need a spectrum analyzer and a tracking generator. Well, many of you probably have the Nano VNA. It will do the same thing, but this little thing is so complicated for me, I can't work it. So instead, today we're going to be using the rigol dsa815 spectrum analyzer with the tracking generator. And we're going to set that up to tune these cavities. Now, we got 4 cavities here. 2 are for the receive side, 2 are for the transmit side. And the repeater split is a 5 meg difference in frequencies. So right now, what I'm going to show you is just we're going to tune the receive frequency cavities, and the tuning is the very same for the transmit cavities. So let's do this. Let's hook the generator up here. Well, first of all, we need to do the cavities individually, and then we'll connect them together, and then we'll kind of fine tune it. So I'm going to take off the connector here. And here, now since this cavity is a passive cavity, there's really no in and out to it. So I'm going to take the signal generator cable right here. We're going to go into the cavity here, and then the receive cable here off the spectrum analyzer. We'll put this in the other side of the cavity right here, so I can reach down in here. It's kind of crowded. Okay. So, we've got our signal generator going in one side, and we've got our spectrum analyzer on the other side. Let's set our spectrum analyzer up right here. So, we know our frequency is going to be 462.55. So, I'm going to put frequency in here of center frequency of 462.55, and it's megahertz. Let's do a start frequency of something below that. We'll say 450 megahertz. and we'll put our stop frequency of, say, 470 megahertz. So that's going to give us a look at the cavities from 450 to 470, and we're gonna see how the cavities tune. Let's turn the tracking generator on. So let's see, tracking generator's on, 0 dB. Okay. All right. So we're generating now, and you can see there's our 0 dB reference line. We're transmitting with our signal generator at 0 dB. There's our 0 dB line. That's the signal strength of the generator. You can see right there, it's almost right on the line. But we need to try to tune these cavities. So let's do this. Let's put the center frequency. We'll go marker, or let's see, marker. The frequency we want to pass on this one is 462.55. So I'm just gonna key it in here. 462.55. Let's see. Let's see. Okay. We're gonna key it in right here. 462.55. Well, 462.5. That's good enough right there, just for demonstrating this. All right, now, okay, we go marker and normal, 462, we need to be on 462.55. That's good, 462.56. Let's turn our marker on here. Okay, so I've got this marker, this little one here is our marker for 462. It's set. See, I can move it back and forth. Right now, I've got it on 462. I want to put it on about 5.5. 5.6 is good enough for now. You can see we're passing here. We're actually rejecting here. So let's do this. Let's turn the cavity here. We're going to adjust this cavity a little bit by just turning this right here, and we should be able to move that bump over to where that one is. So here we go. You can see it's moving over. You can see it's moving over. And here's our attenuation, or the loss of the duplexer now. Right now we're losing 7 dB through our duplexer. So let's keep coming. Look at there. We're bringing our cavity over to our frequency we want to pass right there. And the difference between what our generator is putting in and what our cavity is putting out is only about 1.48 dBm. Okay, so we've got that one kind of peaked. Now, 5 megs up at 467.55 is our receive frequency. So that's what we want to put here on the duplexer. So I'm going to move this frequency to 467. 467, like 5.5 there, 5.6. There's 467.56. So we've set that one properly. There's where we need our notch there, but our notch is down here. So to fix that, to move that notch, we've got to move this little tab that's inside here, just by loosening it and sliding it like this. It's kind of hard to do. So let's watch the meter up here now, and I'm going to slide this, and we're going to try to get that notch right on. We're going to try to get that notch right on the frequency. And it's real touchy. All right, we're close there. What I'm going to have to do is this. I'm going to have to kind of bump it. I'm going to put me a nut driver over it. I'm going to just kind of tap it a little bit. I've got the thing kind of just a little tight, but I'm going to bump it now. If you'll watch here on the meter up here now, as I tap it, you'll see we're changing the frequency slightly. Look, see, we're off frequency. I'm trying to bring it down on frequency. All right, that looks pretty close. Oh, that looks pretty close right there. So, all right. So what we've got now is we've got this notch at 467.56. Let's go 5 megahertz up or down. We're going to go to 462.56. Right there. All right, so I'm going to turn the knob and try to peek out again just a little bit. I see we have an insertion loss of about a minus 0.1. Let's see if I can make it any smaller. Oh, there's 0.4. 0.5. Okay, that's probably as close as we'll get it. If you remember, the specs on the manual said 2 dB, a minimum of 2 dB loss. So we're real close there. I'm going to go back, since I turned that, I'm going to go back real quick to our other frequency that's 5 megs higher, which is the 467. There we go. See, we moved a little there. So I'm going to readjust it. I'm going to readjust it a little bit. Trying to move it down. There it came down. Okay. All right. So it's kind of a back and forth deal. It's kind of a back and forth. Let's go back up to 467. 462. 56. Okay. Okay, that's pretty good. Let's look at the delta. Now this is delta pair. All right, this is going to show us in dB. If you'll notice now we've got a 1R up here for our marker. And on delta, I'm actually able to bring another marker down. You can see a little 1 coming down right there. And we're going to bring that down to here. And you can read the difference in the frequency right there. You can see 5 megahertz difference. There we go. And that cavity right now is giving us about 44 dB of isolation. Okay, now we've got that one done. Okay. All right, so that's tightened down. So what we're going to do is we're going to tune the other cavity, just like we did that one. I'll put this back. I almost put it in the wrong place. So as mentioned, the cavities here are pretty critical. The length of these cables are actually very important, and they have to be the right length to make everything in here work right. All right, so we're gonna just do the same thing to the second cavity. Really quick here. We're gonna take our generator. We're gonna go in one side. That's a stiff piece. It's a little hard line is what it is. All right, we're gonna take our spectrum analyzer. You need to get those tight. If you're not tight, you'll have dB loss there. So, okay, there's our spectrum analyzer. And into our spectrum analyzer. All right, let's look at it again now. Okay, so this cavity is not tuned. Again, we want to pass 462. There's our pass right there. You can see. Let's see what our pass is on. Yeah, it's not good. I'm gonna put this marker down at 462. Right there, and we got to move this filter down to this frequency right here. So I'm going to turn the big knob here on the duplexer. Okay. Now, if we look at the scope up here as the analyzer as we're turning it, you can see I'm bringing the frequency, the pass frequency over. It's coming over. It's coming over, over. I'm still turning it. So right about there, we're passing the most signal. 0 is our reference, and we are at, let's see what we're at. Let's look at something here. Okay. All right. that looks good. Now let's go to our reject frequency, which is going to be the 467.56 right here. So our cavity is not tuned for reject here. So I'm going to move this little stub again right here. I'm going to move this little stud right here. And the best way I found is to snug it down and put something over it like this and just kind of tap it to move it. All right. Oh. All right. If you look up there again, that little 1 is right on frequency. So I'm going to tap it and try to get that 1 right on the notch there. There we go. That looks like it. We're going to go back now. We're going to go back here and we're going to repeak. We're going to repeak this. Looks like we're pretty close. And then we're going to go back and look at our notch one last time on that one. Put our notch back on 167.556. And if you look here, we're at 5 megahertz split from here to here. And minus 45 isolation there. Let's look at the delta pair again. So let's see, delta pair. Oh, I was already on it here. Yeah, we got about a 45 dB isolation. Okay, now. Okay, so let's put the two cavities back together in series with each other. We're going to just put them back in line here. So this is the transmit side. These two are the transmit side, 462.55, and we're going to see how the two work now tied together, and see what kind of isolation we can get. Let me get this in here. You might think that's funny. That's the wrong way for the T connector to be in, but I've looked that up, and this is the proper way for that T connector to be installed on this duplexer. All right, let's do that. Let's hook the other one up right here. All right, you know, the other cavities are in line now. The received pass cavities are in line. I've got a dummy load on here just so it'd be terminated right here. All right, let's look. Oh, look up here now what we've got here. Wow. Okay, so hey, here's our pass frequency here. And then here's our reject way down here. So right now we're showing almost 88, almost 90 dB of rejection. You know, each of the filters was showing about 45 earlier. So let's see if we can fine tune this a little bit. I want to be right on this frequency here, 467. Oh well, we want to pass the 462. 462. That's where we've been adjusting, 462.56. Okay. And we're showing about 3 dB, 3.7 dB of loss in the duplexer there. That's not great. And if we look here though, we're off here. If we move the frequency to our peak here, you can see this is coming down here. That's 2.99. But look at the frequency. We're down at 462.266. So let's put this frequency back on 462.566. Let's see if we can move this pass over. And I'm going to do that by just trying to fine tune the knobs here on the analyze, I mean on the thing. That's not doing much. That one did. That one moved it over a little. Yeah, we're down to minus 290, so that's pretty good. Let me touch the other one up a little bit. I'm going to watch this number right here. I can't tell too much about the peak there, but I'm going to watch that number. 277, 28. Okay. We're going to leave it right there. And still fine tuning, barely turning. We're going to leave it right there. Let's check this notch here again, right here. So let me take the frequency back down to the 467. 467. This is 467.56. See, we're off a little right there. I'm going to try to adjust those notches again. It gets really critical here. It don't take much movement. So I'm just going to tap those little things again. Let's see. I think it's coming down a little bit, maybe. I don't know. Let's see. Let me see if I can get the other one. There's two of them here. Wrong way. I think that's it right about in there. So, wow, look at that. And if you look right up here, our duplexers now are giving us about 95. Let's go to this. Let's go to dB right here. Let's see, between that marker, delta. Gotta make a couple of adjustments here. Okay. Yeah. Right now we're seeing between our pass and our reject, and our reject is off a little bit. We're showing about 92 dB rejection. Let me see if I can get it a little bit better. It's getting touchy now. Oh, wrong way. Making it worse. Oh man, getting really worse here. Tapping that over a little bit. Try moving the other one a little bit. Nope. Somewhere in there. And oh, it's really touchy. Really touchy. All right, I'm gonna leave it at 90 dB right now. I'm gonna touch the knobs up, the actual thing, just a little bit to see what happens here. We're so close, 94. We're at 94 dB. 94, well, 92, 93, 94. All right, and just quick tuning. That's about as quick as we can get it. But as you can see, our duplexer now, we're passing at our receive frequency, and we're notching out our transmit frequency down here. So we do the exact same thing. We do the exact same thing here. We do the exact same thing here with the other two cavities, except we reverse the two frequencies. It's going to look just like this. You're going to have a pass and you're going to have a notch. And so again, we'll adjust the knobs. We'll adjust the little tabs right here that will slide in and out, and adjust these two. Go. Okay, so you can see how handy a spectrum analyzer with a tracking generator is for tuning cavities and things. And it brings to mind, you know, a lot of people might want to just cut a quarter wave open, you know, for a filter. So let's test one real quick. So I'm going to take the spectrum analyzer here. Look, I've got just a piece of coax here. And it's open on the end. Let's make this a filter. So look, let's go over here real quick to the computer here. I want to look at a couple of things. Oh, this is interesting here. Well, let's see if I can get it where you can see it better. Okay, you can see right here you can see the T adapter right there, and you can see coax to the antenna and coax, say, to a receiver. And this is the stud right here, that we're going to be cutting here. It's quarter wave length, open end. So let's see if we can do that for. Oh, and look, another thing you got to do. This distance right here has to go to the center. The distance here has to go to the center of this connector. It can't go just to the end of the coax. A lot of people say when you cut this coax, measure to the end of the connector. Well, if you use a T, you're going to have to go up to the center of the T, because that becomes part of the length of it. All right, so let's do this. I don't know what frequency. I have no idea what frequency this is on. Well, let's do something. Let's do a quarter wave matching stub right here. And this website's pretty neat. You know, let's put a frequency in here, say 100 megahertz. 100 megahertz. We know the velocity factor on this cable is 0.66. See, I need to clear all this. Let me see. How do I clear this? Well, let's see what happens. Okay, so I put a frequency in of 100 megahertz right here. Velocity factor 0.66. All right, so we had a wrong number in here. So we're going to set our frequency at 100 megahertz right here. We did a calculate, and it says our length of our quarter wave stub should be 0.495. Now, this is European. They use commas for periods. I learned in my job over the years. So 0.495 meters. Let's put 0.495 in here. 0.495, and that should give us 19.48 inches. 19.48. I'm gonna write that down right here. 19.48. All right, 19.48 inches to the center should give us 100 megahertz filter. So I'm gonna short it out. Let's measure 19.48 very quickly from the center. From the center of that T, 19.48. Oop. 19. All right, about there is 19.5 right there. All right, so I've got 19.5. I bet you it's not going to be 100 megahertz. I bet you it's not. Notice our end is open. And again, we're using RG58 coax. You get a much better filter if you use something like RG213 or LMR400. Okay, so we cut this at 19.48 inches long. It's open on the end. And our calculation says that should be a filter for 100 megahertz. Let's put it on the spectrum analyzer and see how many bet it's going to be on 100 megahertz. How many think it's going to be there? Well, we're going to find out. I don't think it's going to be there. I think it may be higher. I think it may be, I don't know. I'm guessing 110. I'm guessing 110 megahertz is where the filter is going to be. So what we're doing here, we're just putting this T in. We're putting this T in right here. So we're coming out of the tracking generator. We're going through the T. We're going back to our spectrum analyzer. On the T here, we have our 19.48 inch open quarter wave stub. Let's see what the spectrum analyzer says it is. I'm going to set the I'm going to set the, let's see, what am I going to set? I'm going to set the start frequency. We're going to scan this. I'm going to set the start frequency about 50 megahertz. 50, and I'm going to put the stop at, say, 150 megahertz. I see a dip. I see a dip. But let's see, is that going to be 100? I don't know. I'm going to turn the marker on, and we're going to bring the marker down to that point, and we're going to see. I'm bringing that marker down, and as you notice, it's changed the frequency here. Ooh, look, we're at 117, 115. Bring it down. 113. It looks like when we cut that quarter wave opening the stud, it is at 112 megahertz. All right. So look, we wanted 100 meg. We wanted it to reject a 100 meg signal. So let's do this. Let's trim a little more off and see if we can bring it down to 100. So I'm gonna cut off about a quarter of an inch. All right. I cut off a quarter inch. Uh-oh. You know what? I took it the wrong way. I should have made it longer. I knew that. I knew that. Now we're filtering at 114. Okay, let's just say we wanted to filter at 120. We wanted a 120 megahertz filter. Let's just cut it off till we get to 120. Tell you what I'll do. I'm going to put this at 120 right here. See the frequency? I'm going to go up to 120 right there. All right, see where the 1 is right there? So our notch is below that. So I'm going to just keep trimming off. I'm going to keep trimming off until I get up to where that 1 is, right in the notch there. So here we go. There's an 1/8 of an inch. Ooh, it didn't take much off. There's another 1/8. Did it take any off? I couldn't tell. I'm going to take a 1/2 inch off. Oh, look, a 1/2 inch is getting closer. I'll take a 1/4 inch off again. I'm going to take another 1/4 inch off. Look at there. Now our filter is at 120. So you can see it's not there. Now, the interesting thing is, it's only about a 23 dB notch, so that's not a whole lot, but it might help if you've got interference coming in from an antenna. You could put a stud on there, and you could easily get maybe 20 dB of isolation on that signal. Now, what you could do is go 1/4 wavelength more this way and put another T here, and you could put another 1/4 wave stub right here, and you could probably double that, so you'd get about 40 dB. But anyway, that's kind of our experiments on cavities, duplexers, 1/4 wave open stubs. So hope you enjoyed it.